Hello everyone, myself Ganesh Ranjan Chauhan. I am a member of Group 10 of Data Science Project along with Atharv, Rajiv, Krishna, Mohit and Nihal on the topic Know Your Habitat. So the first questions which come to our mind is what is the objective of this project? So in this project, we had to design a software that accepts media files which can be photos, videos, etc. of IIT Mandi North Campus, South Campus and Mandi City and then identify the place from where the building belongs and it is which building. So let me now give the basic overview of what we did. First of all, we used CNN for classification of images in North, South and Mandi. What is CNN? CNN stands for Convolutional Neural Network, which is a specialized neural network for processing data that has an input shape like 2D matrix. Take the example of an image. CNN are typically used for image detection and classification. So what next? After this, we then converted it into a 1D matrix and passed it to many FC layers. The final layer of FC layer contains same number of neurons as much as the number of features. We also used YOLO v4, that is you look only once, and YOLO v4 is the latest version of YOLO. It is an object detection network and it is one step object detection network and is composed of three parts.
Hello everyone, my name is Mohit Singh and my roll number is V21056. I'll be explaining that why we use convolutional neural network. A convolutional neural network is a subset of machine learning. It is one of the various types of artificial neural networks which are used for different applications and data types. CNN is a kind of network architecture for deep learning algorithms and is specifically used for image recognition and tasks that involve the processes of pixel data. There are other types of neural and deep learning, but for identifying and recognizing objects, CNNs are the network architecture of choice. This makes them highly suitable for computer vision tasks and for application where object recognition is vital, such as self-driving cars. Artificial neural networks are a core element of deep learning algorithms. One type of ANN is a recurrent neural network that uses sequential or time series data as input. It is suitable for applications involving natural language processing and NLP language translation, speech recognition, and image captioning. The CNN is another type of neural network that can uncover key information in both time series and image data. For this reason, it is highly valuable for image related tasks such as image recognition, object classification, and pattern recognition. To identify patterns within an image, a CNN leverages principles from linear algebra such as matrix multiplication. CNN can also classify audio and signal data. A CNN's architecture is analogous to the connectivity pattern of human brain. Just like the brain consists of billions of neurons, a CNNs also have neurons arranged in a specific way. In fact, a CNN's neurons are arranged like the brain's frontal lobe, the area responsible for processing visual stimuli. This arrangement ensures that the entire visual field is covered, thus avoiding the piecemeal image processing problem of traditional neural networks, which must be fed images in reduced resolution pieces. So now I'll be talking about the how was the dataset of the CNN build. Dataset that we built for the CNN. It majorly comprises of three folders: North Campus, South Campus, and the Monday City. This is the dataset for the CNN. It comprises of three folders, different images of South Campus buildings from different angles, and similarly for North Campus and the Monday. After we have given an input image to the CNN, it immediately classifies into three classes: North Campus, South Campus, and the Mandi City. That's the folder that we have made.
So myself, Krishna, and now I'll be beginning with the code part for CNN. For the deep learning libraries are here. So TensorFlow and Keras are the main libraries being used here. So these libraries have main functions, important functions like Cove 2D, max pooling, and global average pooling. So these are very important in like doing classification. So here in this cell we have mounted the link of our dataset into the like this code. So here we have defined the resolution of our image like 200 into 200. So we have resized this basically into these many pixels. Here like we are doing okay. These are the parameters of the image. So three here represents the three colors of the image of each pixel, and image height and image width are the height and width respectively. So here like in this set, what we are doing is we are pre-processing the data. Like firstly, we are splitting the data into train data and test data. So 80% is the train data and 20% is the test data. So this is the part for that, and we are rescaling it also over here. Like all the images get rescaled. So batch size is being defined, and batch size is chosen as 32 because it is standard. It is being used. So yeah, this is our training images and these are our testing images. And in the end, we have three classes which are like North Campus, South Campus, and Mandi. So at the end, they will be classified into three classes. So in this cell, we have printed 25 random images from our dataset. These can be from all the three classes. Here comes the CNN part. So in CNN part, what firstly we have imported the weights from ResNet. What ResNet had is ResNet has predefined weights in it. We modify their weights according to our data, and then we use it to train our neural network. So here, what we are doing is using some classes from Keras. So firstly, we did batch normalization, and then we use this function global average pooling, and then in the first hidden layer we use 512 neurons, and in the second hidden layer we had 256 neurons, and after that we dropped 0.5 fraction of neurons to avoid overfitting. In the last hidden layer we have 128 neurons, and all the three hidden layer had activation function as ReLUs. What ReLU does is it results an output from 0 to 1. And in the last hidden layer we use softmax activation function because it is fast, and we also use or ADAMAS or optimizer to minimize the loss. And just to check our model summary, we have printed it over here. Here we are training our data in 15 times. So 15 times our data gets trained. So an epoch represents a cycle of training. So 15 cycles. So here we are visualizing our model, checking our validation loss and training loss. So here the validation loss increases and the training loss decreases. As increase in epoch, or training loss decreases. So that's the desired thing. So here's a test image, and now we will classify it as north, south, or Mandi. If output comes as 1, then it's North Campus. If output comes as 2, it's South Campus. And if output comes as 0, then it's Mandi. So let's check the output over here. So output is 1. Our image belongs to North Campus.
Hello, my name is Nihal Singh, B21059. Basically, I have contributed in the concept building in this project. And now let's see what is YOLO, how is it helpful to us, and why are we using it. YOLO models are object detection models, which are trained to detect object in the image. In these object classes in our dataset includes A9, A10, A11, etc. buildings. We have drawn boundaries around those objects so that they could be easily distinguished. Now coming to the next slide. Basically, this is a full complete YOLO model. Here is an image and there is a convolution layer, and these are the CSP and CBMs. Now, what the CSP does. As the number of layers grows, the last layers have a lesser and lesser contrast of the feature learned in the initial layers. In order to solve that, researchers introduced the idea of skip connections, such that gradient can backpropagate to the initial layers with relative ease. DenseNet was one such network that has skip connections from every layer to another. CMP basically takes into account the mean and standard deviation of the past 4 batches and uses them to normalize the current batch and moving forward to SSP block. SSP block is used to increase the receptive field and separate out the most important features from the backbone. Spatial pyramid pooling is that we take an input image and use convolution layers to extract its feature map. Hence, we get the final output like this. Now, moving on to the next slide, let's see how data set is prepared. First, we have prepared a folder named ULOv4. In this, we have installed darknet folder. In darknet folder, we are basically using 3 folders, each which are of main purpose to the data CFG and backup. Data folder contains a folder pyfod, which contains the whole trained dataset, that exe files, annotated files, and the actual image. Pyfod.data contains the relative paths where these training dataset and testing dataset. Pyfod.name contains the list of all the classes which we are going to detect and processed by the Python program made by us, which basically separates the data into training dataset and testing data and stores it in YOLO. And thus, we get the test dataset. The CFG folder contains custom.cfg file, which is mainly used to us. Custom.cfg basically contains the batch number of classes, divisions, etc., and many features. Like this, we are continuously changing the dataset as per the training and testing dataset. Like this, we are continuously changing the dataset as per the training and testing dataset. Backup folder contains the training weight after a particular epoch. Like here, we have given the trained weights after 500 epochs, 1000 epochs, and 1500 epochs.
So hello everyone, my name is Athar Kumar. My roll number is B21038, and I was basically involved in the coding part of YOLO and also helped in the coding part of CNN. So this is our code for YOLO, which basically does the object detection. In the first part, we are mounting the Google Drive. In the next drive, we are saying that in this whole address, we can inside of this whole address, we can just write my drive. Then we are entering into the YOLO v4 by fold folder, which are created by us. Then we are just cloning the darknet library or installing darknet library from internet, and then we are we are entering to a darknet library and changing and make changes in the make file. What we are changing in the make file is like we are using one GPU in this, so we are changing the GPU value from 0 to 1. Similarly, from CUDNN from 0 to 1 and etc. and this command basically executes all the above commands and initializes them. Then here we are getting the installing the YOLO weights, which we here can see it is installed in YOLO v4 weights.7. Then we are basically changing the permissions of the darknet folder in this line. Basically, if we do not change the permission of darknet folder, the darknet will not allow us to train on custom data set. Then here we are just going into YOLO before Python library darknet data, and we are executing process.py file. What process.py file does? Process.py file basically divides the data into training and testing data set. Here is the process.py file. Let it load. Here is a process.py file. This is a current directory, and the split pack we are dividing into 90% train data and testing percent test data, and we are storing in the required format. Then here we have few more which are required. This is py4.names and py4.data. Py4.data basically contains the addresses of train and test files, and py4.names contains all the classes which are present. Now let's move on. Now we have entered a CFG folder. Then we are changing our batch from 1 to 64. Basically, in the CFG folder, there are all subdivisions. Batch 1 to batch 64 and subdivision 1 to 64 for a training purpose only. Then we have trained our data in this line. Here we can see the data has been trained. It has been trained to 3000 epochs, and it took us nearly 6 to 7 hours to train such data. Basically, now for testing purposes, we are changing again a custom.cfg file from batch 64 to batch 1 and subdivision from 64 to subdivisions 1. And here we are testing our files, and here we have test the file in this command detector test by for the data. We are calling a CFG file and giving us the address of our final weights which are going on, and this is the final image. Now let's move on to some folders. Basically, let us first see what is the YOLO format. First, if we use a bbox tool, it gives XY, object height, and object width. But we can see it does not contain the classes to which the image contains. So that's why we use a convert. We have created a convert.py file, which basically takes out all the classes and then uses a bbox tool to label them all. And this is a convert.py file. I'll show you. So this is the final YOLO v4 converted file. There is 13 is the label, and this is all the XY object height and object width converted in YOLO v4 format, and thus we are using those object height and object width. And here we can see in the backup folder we contain custom weights. We does not contain custom weights, but the modified weights which we have got for training like YOLO before custom final one weight. This basically is from 1000 epoch, this is from 500 epochs, and this is our final epoch which is around 2000. And so here we can have tested data, and like this is tested data, and we can like see it is predicting pretty good, um, which is which goes on like Gymkhana 80%, Health Center 30%, A12 38%, and it goes on as the epochs went on. And here we are basically showing the image, and that's all for the code.
Hey everyone, this is Raju Sharma, B21064. I worked on design interface section. Here we use HTML for our front end and Flask framework for our backend part. Now just a little overview to our HTML code. So here we put our background image, a navigation bar, footer, and a form that will accept our input files. Now let's jump directly onto our website. Here we choose 3 random images as our test sample. Now we take the first one. Now I know this image is of health center in North Campus. So now let's check whether our model classified it correctly or not. So yes, our model correctly mentioned this image as North Health Center. So let's discuss how it's working. So our CNN classifier first classified this image as North Campus image, and further classification is done by our YOLO model, and it classified this image as Health Center. Now we understand the working, so let's choose another image. Okay, now we choose our second image. Again, I know the left building is A10 and right one is A9 in the North Campus. So let's see how this model classifies this image. Okay, here's the result. Our model correctly mentioned each building as expected. Now it's done for the last image. Now I know that this is our Gymkhana building in North Campus. So let's open it as well. Great. Our model classify this building correctly as Nor Jamkhana. So in the end of the day, we clearly see from our test run, each building is classified correctly. Now I would like to conclude our presentation. Here are the roles and responsibilities of our team members, and I hope you like our project. Thank you.